Some important information you need to know before you go on is about the angle of elevation and the angle of depression. So I'm going to draw you a crappy picture like I always do. But if I have a building here and a person here. Sorry guys. And then I am going to put like a, I'm going to put a person up here. Okay. So the difference here in the two is that if it is an angle of elevation, we're talking about between the line of sight and observer to an object at a higher level. So like it goes up to here. And this would be like your line of sight, your horizontal line. So the angle of elevation is this angle here. And then the angle of depression is between the horizontal line from the line of sight. So I have to draw a line here. And this one here is the angle of depression. Now, this is where people get confused because they often think that this one here is the angle of depression, but it's not. It's from this horizontal here, like from your eyes, looking out and then looking down at the person. So knowing the difference between those two is important for when it says like the angle of depression, making sure you're labeling correctly. This problem is going to take quite a bit of paper, so just be prepared for that. Give yourself some room. So we're talking about Mount St. Helens here, and we know that the top got blown off. So we're going to find the new height, and that's labeled H for you. So a surveyor measured the angle of elevation of the volcano to be 37. So I think that's this one, 37 degrees. And then he moved 1,000 feet closer, and he found this angle here to be 40.5 degrees. And it says, determine the new height, the new angle of elevation, the new height. But we don't know this piece either. I'm going to draw that in there. And then I'm going to think about this whole piece as x plus 1,000. And the reason that I'm doing that is we need to be able to find that distance before we can find h. If we're looking at this, we've got opposite of our angle, and then we've got adjacent. So I'm going to use tangent because I have opposite and adjacent. So I'm going to make two equations here. So one equation is going to be for my little triangle here. I'm going to outline in purple. So tangent of 40.5 degrees is going to be opposite over adjacent. I'm going to make another one. I'm going to use my 37 degrees, and that's going to be this triangle. So the bigger one is opposite over adjacent, which is this. So at this point, I have two variables. So I need to solve for one in terms of the other and use substitution. Okay, so that's what I plan on doing. I'm going to take my blue equation and solve for h. So that would mean I would multiply both sides by x plus 100. So I have 1,000 times tangent of 37 degrees would equal h. And now I'm going to take that, what I know here, and I'm going to plug it in right here. Okay, so I'm going to plug all this in right there. So I've got tangent of 40.5 equals h, but I know h is x plus 1,000 times the tangent of 37 all over x. Okay, and the next thing that I'm going to do is I'm going to distribute here. So I've got this. Let me kind of shrink my page and move up a little bit. Okay, so I have tangent of 40.5. Let's see if I can write a little smaller here. Tangent of 40.5. Oh, okay. I want to erase that. Guess I can't do that. All right, so the tangent of 40.5 equals tangent 37 times x plus tangent 37 times 1000. That's still all over x. Okay? So as I'm going along here, I think I pushed the wrong button when I wanted to erase. As I'm going along here, I'm going to do something now that you guys normally do in a different manner. So normally, I'm going to make a note over here, if I had 3/5 plus 1/5, you would combine them by saying like 3 plus 1 over 5, which would be 4 over 5. I'm going to work backwards. I was here. Okay, now I did here, and I'm going to split it like this, meaning that I'm going to take this and this and make it like two different equations, for example. So I've got the tangent of 37 times x over x plus the tangent of 37 times 1000 all over x equals the tangent of 40.5. Okay, so I did this for a specific reason. Not just because I wanted to confuse you, because once I have it split up, I can cross off these x's here because I have an x divided by x. And so now I only really have one variable left, which is kind of nice for me because I know that I can solve this now. So tangent of 40.5 is a number. Tangent of 37 is a number. It's something that you can be typing in your calculator. And now I don't have a calculator up here, and I don't think Explain Everything has one, so I can't bring one up. So I did this earlier, and I'm just going to kind of keep going here with this, and then I'll fill in my numbers. Hopefully you pause. So now here I have the tangent of 37 is all that's left. And over here I have tangent 37 times 1000 all over x. I'm going to move my page up a little bit. I know I'm writing over the next one. So tangent of 40.5 I have is 0.854, and tangent of 37 I have is 754, and then plus this will be 753.55 over x. Okay, so right now I'm just trying to solve for x, so I'm going to subtract this. Okay, and I'm going to have 0.1 equals 753.55 over x. So to get rid of x on both sides, I'm going to multiply by x. This is 0.1. So now I have 0.1x equals 753.55. Just talking through my algebra here. So then I got x equals 7535.5. That's x, guys. Here's the problem. That was just x. Yikes. We are nowhere near done. I have to shrink and go back to the top. Because I know, for example, I'm going to use black, that tangent of 40.5 was h over x. And we just solved for x. We were looking for h here. So the last step then is to solve here. And I don't have this one worked out in front. Oh, yes, I do. So I'm going to multiply both sides by this, which was x, right? And that crosses these out on the bottom. And so I'm going to have the tangent of 40.5, which you're going to type in your calculator, times this, and you should get, I got 6,436 feet. Okay, so this was a really, really, really long problem.